Okay, so now we're going to look at solving two-step equations. And what that means is we'll just have equations that have either multiplying and dividing and also addition or subtraction or any combination of those. So time out, you've got to look at this. Remember, the same as you've done every time before, you have to get the variable x by itself. So that's what your goal is, to get x by itself. And you have to remember to do to one side what you do to the other side. So you have to balance that out. It's got to be equal. So the way that this would work, this would be a two-step because it has multiplication and addition. And so we would set it up as 2 bars and then 3 positives, okay? And that represents 2x plus 3. And then we have 7 over here, positive. Now, our goal is to get x by itself. Well, there's 2 x's. Well, you work order of operations or PEMDAS backwards. And so I'm going to deal with the plus 3 first and get rid of that. So to get rid of plus 3, I have to add negative 3. And whatever I do to that side, I have to do to this side. And this would zero out, and this would zero out. So that leaves me now with 2x equals 4. Now you remember from the multiplying and dividing video, this would go with 1x, and this would go with the other x. So now we say x equals 2, because 2 of these are going into each one of these bars. And so x equals 2. Now let's put it all back in to our equation. So I've got 2x plus 3 equals 7. So 2 times 2 plus 3 equals 7. So 4 plus 3 equals 7. So 7 equals 7. So that's how it works. If you were to look at it with the numbers, 2x plus 3 equals 7, you would take 3 from this side and 3 from this side, so that would leave you with 2x equals 4. And then to get x by itself, you divide by 2, and you get x equals 2. So it works out with the numbers, it works out with the model, and it checks. Big check. So 3x minus 2 equals 7. So now I've got 1, 2, 3. And I've got a negative 2 of them. And that's going to balance out or equal to 7. 1, 2, 3, 4, 5, 6, 7. So I've got to start with undoing the addition or subtraction, and this time it's subtraction. So I've got to add 2 on this side and balance it out with 2 on this side. And that 0 pairs, and nothing 0 pairs here because they're all the same sign. So now I'm looking at 3x equals 9. So these 3 would go here, and these 3 would go here, and these 3 would go here. So there would be 3 in each x. And so x equals 3. Now let's put it back in and see if it works. 3 times 3 minus 2 equals 7. 9 minus 2 is 7. 7 equals 7, so check. Now if I were to do this mathematically, I would say 3x minus 2 equals 7. To get rid of the negative, I'm going to add 2 on both sides. So add 2 here and add 2 here. And so that's 3x equals 9. And then divide by 3 and divide by 3, x equals 3. So it checks out. So again, with the model, mathematically, and making sure and substituting in for the check. So 4x minus 3. So go ahead and stop the video and do this problem, and then whenever you come back, you can check your answer. Okay, so you can see it looks kind of messy. I balanced out these 3 negatives with 3 positives, put 3 positives over here, zeroed out, and that left me with 4x equals -8. And so I put 2 negatives in each one of these. 2 negatives in each one. Okay, so x equals -2. That's a -2. And then I put it back into my answer, and I saw, yes, it's a -2. Whenever I first did the model, I thought the answer was 2. And then I was like, oh my goodness, that doesn't work out with working it out mathematically. It is a -2. So you need to make sure and watch your signs and what's going over into the bars. So let's look at a division 1. And so the way that we're going to set this up is first make our x, and it's divided by 2. And we need a -3, -1, 2, 3. And we've got -6 on this side. Okay, so now I'm going to zero pair these out by adding 3 positives, and so that goes away, and adding 3 positives, so that goes away. So I'm left with -3. So that means that -3 goes here and -3 goes here. So -3 plus -3 is -6. So my x equals -6. Now let's put that back in and make sure it makes sense. So -6 divided by 2 is -3, minus 3 is -6. So it checks. And you can do it mathematically. X divided by 2 minus 3 equals -6. You're going to add 3 to this side, add 3 to this side. So x divided by 2 is -3. And then to multiply by 2 on both sides would be x equals -6. So it checks both ways. Okay, and sometimes you're going to be given variables on both sides of the equation, and you're still looking to get x all on one side, x by itself. So you have to draw the model of what's represented in the problem. Here's 2x, and then -4. And then you have x on this side, and a +6. Okay, now the first thing you can do is you can look at the x's and see if there's anything that cancels out. So since these weigh the same, you can just cross them out from both sides. Now you have 1x. And so now this looks like x minus 4 equals 6. And you would solve it just that way. You would add 4 here, add 4 here, and so x equals 10. And put it back in and make sure it makes sense. So 2 times 10 minus 4 equals 10 plus 6, and that's 20 minus 4 is 16 equals 16, so it checks. Now this is where I've been telling you not to try to do these in your head, because when you get to this point, you really need the models and the understanding of how things are canceling each other out. Okay, so now you want to be given the model, and you need to say what equation it's showing. So this is just 2x minus 3 equals 1, 2, 3, 4, 5, 6, 7 equals 7. That's the equation. So to solve it, I'm going to add 3 to this side and add 3 to this side. And now I have 2x equals 10. And I can do the whole, okay, this group goes to here, and this group goes to here. And that's 5 of them, 2, 3, 4, 5. So x equals 5. And if I put that back in, 2 times 5 is 10, minus 3 is 7. 7 equals 7, so it's checked. So you do this one and then come back and see how you did and if you did it right. Okay, so what's being modeled here is 3x minus 5 equals negative 11. And I did 0 pairs, got rid of all the red on this side, added it to this side, 0 pairs. That left me with 3x equals negative 6. So 2 negatives went in each of the boxes. And so x equals negative 2. And then let's plug it back into the equation and make sure that it works. 3 times negative 2 is negative 6, minus 5 is negative 11, so it does check. Okay, variables can be represented in many ways as long as a key is provided. So this tells you that these are x, and this is negative ones, and this is x, and this is positive. So let's do this. Let's write it out. 3x minus 2 equals x plus 2. Okay? So in the model, you can cancel this out and cancel this out because they weigh the same. And then I want to add a positive, positive to zero this out and add a positive, positive. And now it's 2x equals 4. Well, of course, 2 of these are going to come here, and 2 are going to come here. So x equals 2. And let's see if that works out. 2 times 3 is 6, minus 2 is 4, and 2 plus 2 is 4. So it checks, it balances. So again, this was a time whenever you had x on both sides. So some key points to remember: get the variable by itself on one side, work backward to get the variable alone opposite of PEMDAS. So we took care of the addition and subtraction first, then the multiplication or division. And whatever you do to one side, you must do to the other. So here's your homework check. This, you're just saying what equation is being represented, and then you solve for x. And then you need to model on your own this equation and solve it and put that answer in your homework check.